Welcome to the Elementary Alternate Assessment Math Targets training. And I am Vonda Adams. I'm a Math Achievement Gap Specialist here at KVEC. And I am very pleased and honored to get to work with you all today. I have a great deal of respect for our teachers who work with our low incidence population of students. I admire you greatly for your patience and the love that you have for your students. So today we're going to go ahead and get started with our PowerPoint, and you'll see the first one we're going to talk about today. The first set of targets is the number sense targets, and I guess I should tell you a little bit about what I know about with these targets. Is that we worked as a task group. We worked on developing strategies for these. Also, like I was saying, we worked together as a task group on coming up, not choosing these. We didn't, that was not part of our work, but we did take the targets, which are actually the standards. They are the mathematical standards that all kids are expected at their grade level to learn and to master. And we worked with developing, setting some limits on what they would be expected to be assessed on. And then we also tried to come up with some activities, and we came up with, I'm sure Cheryl has shared with you before, the document that we worked on with each one of these. So what I want to do right now is I just want to, we probably won't open up each one of these, but we will be looking at a few of them to kind of see what's expected from our students and also what the limits are on on them. But I'm going to open up this first one to give you an idea of what it actually looks like. And I will drop this PowerPoint into the Google Classroom for us, and you will be able to have access to all these features too with it. So you can see it's set up just, if you are familiar with the standards, the Kentucky Academic Standards, we tried to mimic it and make it look as much like that as possible because, of course, we are expected to teach our students the full breadth of the standard. We're not supposed to just stay within the limits. The limit is just what they'll be assessed on, but we're supposed to try to teach it within its full breadth. We're not supposed to not give them exposure to all of it. So the first one here, you can see it always starts with those standards for mathematical practice. And those simply are just what you're supposed to try to target and do with your standards. And they're called the MPs. And of course, the first one there says make sense of problems and persevere in solving them. And it's hyperlinked. You'll see there that these are hyperlinked actually, and you can go to and read more about them. And also down here at the bottom of this page, you can see engaging in the math practices and question stems. That's also another link that you could go to help you with those standards. But we try to embed these standards, these math practices rather, within our standards when we're teaching. So this first one says use place value understanding to round whole numbers to the nearest 10 or 100. And of course you can see in the red, that's where your limit is. Limit to rounding whole numbers within 100 to the nearest 10. Okay, so we're limiting to just nearest 10 is the limit with that one. And of course, it'll give a clarification on it as well over here, kind of giving an example of what we want you to think about. So you can see this is staying within 100. This one, of course, is beyond 100. The Gen Ed standard, I guess we could say. Okay, so getting back to where we are. So here, like I said, we have number sense, and number sense is simply just building an understanding of numbers, knowing their amounts. It also involves a little bit of addition and subtraction as well, but a lot of it is an awareness of place value. And I've listed some tools over here for you. Unifix cubes. When I refer to Unifix cubes, this is what I'm talking about. You should have received 100 of these in your kit. I'd like to divide those into two different colors, and I'll show you in a little bit why that I like to do that, but you should have received those. The bead string you did not receive, but many of you have attended trainings with us before, and you've received those bead strings. Or if you haven't, I can show you real quick. Oh, you did. You got a larger bead string. That's right. You did. You got the one that has the larger beads on it, which looks like this. I almost forgot. I'm not going to use this one for the purposes of displaying for you today, but that one would be great if you're working with your kids and have more than one in a group so they can see them. Also easier for the kids to manipulate, those that may have some fine motor uh, issues. But this is an example of a bead string that's a little smaller, just those pony beads. So if you'd like to have individual ones for your kids, this is something that you could make it's very inexpensive. Just those little pony beads, and we put them in sets of 10, of course, you can see. And just this is actually fishing twine that we use because it doesn't fray and it stays tied real nicely. And then just those little keychain rings rather. And then of course the number line, and we do, you have number lines in your classroom. We gave you this nice little mat that Melissa was talking about earlier, and it also the open number line on it. Open number lines are awesome for our kids. And then of course you have base 10 blocks, and your base 10 blocks are these sets of blocks that came in these packets like this, and we'll work with those in a bit. And then bundles and sticks, uh, you did not have in your kit, but all those are just popsicle sticks. And I sat here right before I got online with you all because my stuff was way too difficult to get to, and it was easier for me just to make myself another set. So it's just craft sticks and rubber bands is all that is, and we bundle them into groups of 10. All righty. So, and you can see that number sense, we've got 2 standards in the 3rd grade, and then there's 2 standards in the 4th grade that addresses number sense. And so like I said, I don't want to spend a lot of time talking about each one. So what I've done is I've just chosen a few for us to look at. And I've tried to look at them in context of questions that your kids might see. So the first one says Johnny has $78. Determine to the nearest 10 about how much money he has and explain how you could prove this. So let's think about the tools that we could use with our kiddos to solve this problem. So we could use, what do you think? Does someone want to unmute and tell me what you think we might could use? Okay. What about a number line? You could use a number line. If you had a number line with your kids, and of course, you could have a number line that's all the way out, has between 1 and 100 for your kiddos. For this case, we're going to use just an open number line, and I'm going to start with, and I'm going to put 70 here and 80 here, and we talk about what would come in the middle, what's halfway between 70 and 80, and that would be 75. And we'd make our tick marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And we talk about and if they need to, then we can go ahead and 71, fill them in, 72, 73, 74, 76, 77, 78, 79. And of course, you have the kids identify where 78 is. So 78 is right here. So thinking about the nearest 10, what's the nearest 10? Here's our 10s, 80 and 70. And obviously they can see that it's closer to 80. To me, when I was teaching my little ones about rounding, a number line was the way to go. And if I could relate it to money, it was the way to go, because kids just relate to money. It's something, it's like a survival skill that kicks in when it comes to money. They can seem to catch on and grasp it way easier. So our next one, and of course that was KY3 MBT.1. So we're going to look at another third grade one. Jane has $45 in her purse and $89 in her nightstand at home. How much money does she have in all? How much money does she have in all? Okay. Now, of course, this standard has a limit with it. It's not within 1,000. The standard says within 1,000, but actually, we're going to stay. Our limit for our kiddos is to limit 2 one-digit numbers or 2 two-digit numbers. Right. So I chose the 2 two-digit numbers here as 45 and 89. So if we want to add 45 and 89, what we can do is we could use bundles and sticks, and we could build. $40. $5. And then we could build 89. And I don't know if I have enough bundles down here for us to build. I don't know if I can even get it on the screen for us. But we could build the 89, 20, 30, 40, 50, 60. We'll pretend we've got 80 down here. And we'll take these, and actually we'll use these for the rest of them. 10, 20, 30, 40, 50, 60, 70, 80, and 90. And of course, you can use your cubes as well for this. You don't have to, you know, this is just one tool. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you can have the kids make bundles of 10. So we're talking about putting all of this together so we can put all of our 10s together, first of all. So we got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. And then we've got all these ones. So we have 130, and then we got all these ones. And so you can talk to the kids about bundling. And before I would even attempt a problem like this, I would have had my kids already working and bundling and making 10s. Taking your units, if you have these, take your single unit ones and bundle them into trains of 10, or take your single craft sticks and bundle into 10. So I'm going to make a bundle of 10. So I had 9 and one more makes 10. So I had 120. And if I bundle this one together, I can grab another. I bundle this one together, that gives me 130, 131, 132, 103, 134. Right? So that's the way the kids can use their tools to build these numbers. We're not necessarily teaching them the regrouping of these numbers, but we're showing them how to do it concretely with tools. And then when we move to the ones that are ready and that can, when we move to showing them that algorithm, where we regroup and we take the 10 ones and we move the 10 over into the 10s place, they'll understand what they're doing when they put it into that abstract and show that algorithm with digits and numbers. Okay. So I'm going to pause for just a minute. Any questions on those two? The next one, we've got compare 435 to 453, and which is greater, and explain your answer. So if we're going to compare numbers like that, we're going to have to use some tools. And of course, comparing is just you talk to the kids about how that's just talking about which is greater or which is less. And you talk about those symbols that you would make. So you could do that with bundles of sticks. Of course, it takes quite a bit of bundles. You take 10 tens and you bundle in to make 100. So that might not be the best tool to use. Um, or you could take your Unifix cubes, and that's quite a bit too if you're trying to build 400. So when I get into those greater numbers, I like to use our base 10 blocks. And you all did receive your base 10 blocks. This is what I'm referring to. So I'm going to go ahead and build 400. And it's going to be hard for you all to see this under this document camera. But I've got 453. So I'm going to move some pins. And 3. And then below this, I'm going to build 400. And 35, like this one's supposed to be on the top. So here's 53 at the bottom. And we got 30 and 5 on the top. Okay, so I'm so sorry. I purposely put these vertically for you. I wanted you to see it this way. And this is the way I always did this with my students. And I worked with primary students most of my career. And at the end of being in the classroom, before I came to KVEC, I was a math interventionist. So I worked with students who needed intervention in math. So this was what I always did with my kiddos, is I would have them line their numbers up. We would build it, and we'd put the hundreds beneath each other, the tens beneath each other, and the ones beneath each other. And we'd talk about, first of all, which is worth more. Hundreds obviously worth more than tens, and tens are worth more than ones. And we had a lot of talk about the place value chart. And if they needed it, then they had that support too. I would just draw me a place value chart on my table, and we'd have it labeled hundreds, tens, and ones. And then we'd talk about, okay, let's look in our hundreds. Well, with this number, there's 400 on the top, and then there's 400 on the bottom. So we'd say, well, okay, those two digits are the same. And then we'd look at the next place. Well, let's look at the tens. Well, on the top, there's 3 tens, and on the bottom, there's 5 tens. Well, obviously, they're not the same. So we talk about which would be more, 3 tens or 5 tens. And of course, talk about 3 tens is 30, 5 tens is 50. So obviously, here's where our change is. So this number will be greater than the number that's on the top. And then we get into that symbol, start writing that symbol. And sometimes that symbol can be really confusing for the kids. And I know some people don't like, you hear about the alligator. My kids always liked the shark story. So we would pretend that I was drawing a shark. And I'll actually show you what I did with mine. But some people don't care much for that. But if you can tell a little story with something, the kids will remember it. That's my opinion on it. So we were looking at 435 compared to 453. And when you get into writing those comparison symbols, the greater than, less than symbols is what I'm referring to. I always told mine to pretend it was a shark, and a shark was swimming around in the ocean. And obviously a shark is hungry, and they're looking for the biggest fish to eat. So which of these would be the biggest fish, 435 or 453? So they would draw, and of course the shark will have its mouth open, and they'd actually like to draw their little teeth in here. It worked. The kids were able to do it. And of course you could make it, into actually a, at first we'd really play it up, make it into a sharp, whole 9 yards, that kind of thing. So whatever works with our kids, that's what we have to do. And they understood. They were getting the concept. They were able to tell me which was the biggest, which number was greater. And then we worried about reading them. That 435 is less than 453. Okay. So I'm going to move on to the next concept. And our next one is focused on measurement. There's only 2 standards in the elementary that work with measurement. The first one, well, first of all, let's talk about our tools. Obviously, it involves telling time, but so you're going to need those clocks. You have Unifix cubes. You can use a bead string for measurement, the number line, and obviously a ruler, a yardstick, a tape measure. And this is not an exhaustive list of tools, I should say. This is just some tools that I was thinking of, some tools that are in your kit, or some tools that are easy for you to come up with. You could most definitely probably add to this list. All of you probably could. So the first one, you can see it's tell and write time to the nearest minute and measure elapsed time intervals in minutes. Solve word problems involving addition and subtraction of time intervals within and across the hour in minutes. And of course, the limit here is to time intervals of 5 minutes. Okay, so we're not having to do it to the nearest minute. We're doing it to the near intervals of 5 minutes. And of course, over here's our clarification on it. As you can see, students solve elapsed time problems using strategies and tools such as clock models and number lines. And it says students can match analog to digital time to 5-minute intervals. Of course, you can use the time lines, actually, literally. Of course, referring to digital, matching the digital to an analog. The next one is a 4th grade standard, and it has to do with converting. So I highly, highly recommend that you have some anchor charts in your room. Anchor charts for the kids. And what I mean by an anchor chart is a chart that's showing, as you can see here under the clarifications, feet and inches. That 1 foot has 12 inches in it, 2 feet has 24 inches, 3 feet has 36 inches. Same thing with your pounds. 1 pound, 16 ounces, 2 pounds, 32 ounces, 3 pounds, 48 ounces. The kids need these things. They need to see them. Over here with time. 60 seconds is equal to a minute. 60 minutes equal to an hour. 24 hours in 1 day. 7 days in 1 week. We need those anchor charts for our kids to refer to and look back at when they're trying to solve these problems that we're asking of them. With measurements, is this first one for MD3, MD.1, KY3, sorry. What time is displayed on the clock? So simply all you'll have to do with some of these will just have displays of clocks and ask the kids to tell you what the time is. Now, teaching kids to tell time was probably one of the most difficult things, excuse me, for my young students to grasp. Obviously, because they don't have really good understanding of time, concept of time, how long it takes to do something, that type of thing. So it's hard for them to relate to it. But I found that my kids, I really didn't know if they knew about time until they could actually set those clocks themselves. So I would highly recommend that you get yourself clocks. If you have to, you can make them out of paper plates and the little spinners and that type of thing, but they are very inexpensive, just little student handheld clocks that so they could set the time themselves. You give them a time and ask them to set it, if that's possible, if they have the dexterity and the fine motor skills to do that. Or you can just show them the clock, and you could have them show them certain times on a clock, and then actually show them what it would look like if it were on a digital display. as well and have them match them up. You could probably do flashcards. I mean, have little cards that they would turn over and match up, matching games and that type of thing with that. So that's just one of your standards, is being able to tell time, display time, um, and also there's of course, that standard involves elapsed time. So you could, but I would not overwhelm them by moving into a next hour or that type of thing. I would try to stay within the same hour for sure when I'm talking about how many minutes has it been from 10:10 until 10:20, that type of thing. And of course, they could count around. And it helps to lay that out as a number line as well when you're talking about elapsed time as well. And then our next one is how many yards are there in 36 feet? That's where I was talking about having those anchor charts and have them to where the kids can refer to them. And those, of course, we can always do that as if it were an open number line. And we're doing yards. And let's say this is what is 0. And let's say this would be 1 yard. And this would be 2 yards. And this would be 3 yards. That's what's nice about an open number line. You can make it whatever you want to make it. We could say the in between here. And our question was how many feet? So we could say that there are 3 feet. We can mark that off into thirds. So in between here and here, there would be 3 feet. And in between here and here would be 3 feet. Marking that off into thirds. And then they could see that they could add those up, 3, 6, 9, or they could count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So just think about using number lines with our kids with measurement. I mean, obviously that's not a yard, but if we've given them lots of exposure and lots of work with open number lines prior to doing something like this, then an open number line is not going to throw them for a loop whenever we try to do this with them. Okay. So any questions on the measurement piece? Okay. I said I was going to switch in Greek, so I want to move to one more before I do. I want to move to this fraction section. I mean, you can see elementary, the largest piece is in fractions. And fractions, they scare people. The word, I tell people all the time, I joke and say it's the F word in math because people are so afraid of fractions because it seems so foreign to them. So, but what we have to do for our kiddos is we have to make it concrete. We have to give them those tools and let them build those pieces and make those fractions. So let's look at what you have in your kit with fractions to work with. We've got some tools. And then of course I'm going to share with you one of my most favorite tools, which is just strips of paper. So first of all, you have in your kit, you have these what I call fraction strips, because they're cut into strips. And of course, with our fractions, they are limited, and when we get into those standards, we'll look at the limits. But you can see the kids can lay these out. What's important about a fraction is knowing what the whole is. And of course, what's nice about these is it establishes what the whole is, and then you build from there. Okay, so that's one of the tools you have, and we'll talk about more of that in just a minute. And then you have another tool that I ordered for you, which is the fraction squares. And I really like the fraction squares. because it allows them to look at the whole and the parts differently. So in this case, blue is the whole. And then you have your parts. And what's nice about these is that the colors correspond, that these browns are halves and the blacks are thirds. So that's really nice that they correspond with each other, that those are labeled and these are not. Then you also have in your kit, you have these fraction multipliers. Now the purpose of the fraction multipliers is to multiply fractions, but we can use them at our elementary level by just identifying fractions. What fraction is blue? And of course it has a little tag right here that you can put your thumb on so they don't see it. I mean, it's labeled for them, that's what I'm trying to say. So this would be 1/2. And then of course, and it's always important for them to see the whole divided into the two parts. So that would be, it is one whole, but it's also 2/2. Right? So you have those that you can use with the kiddos. And then of course, you have these pattern blocks. Pattern blocks are great for fractions. It's just a different way of looking at the whole. You can take that hexagon, and you can take this rhombus, and you can talk about, okay, and you can layer it over here, and you can talk about how much of the rhombus has been covered, or how many parts, how many rhombus does it take to cover the whole. And one of these would be 1/3, 2/3, 3/3. So it's just another way of building and using your pattern blocks. There's lots of uses for our pattern blocks you'll see today. So, and then of course, you can use just strips of paper. You can take just a strip of paper, and I've just got an index card, but you can take a strip of paper, cashier tape, works really well, and you can just fold it until you have your halves. And you can fold it again. And it's really good to have the kids fold if it's possible for them to do that. And here you've got your fours. Okay, so that's just some tools, kind of covering the tools. And then of course, something that's not in your kit that I'll show you here, and these are fairly inexpensive too, are the Cuisinart rods. The Cuisinart rods are just what they are. They're just rods. And they come in different lengths, and you can match them. You can kind of see, you can use these single units here. See how many it would take here to fill that. So that would be, so one of these would be 1/4, that type of thing. So just another tool in our toolbox. Okay. So let's look at our fraction, our standard, and talk about what we're going to do to, and look at the limitations. That's what I want to look at with these fractions. So in the 3rd grade, notice that it is working with unit fractions. When I say unit fraction, that's when there's a 1 in the numerator at the top. And then it's been divided into equal parts. And of course, it's important for the kids to understand that fractions are referring to equal parts of a whole. So the denominator, which is the numeral at the bottom, is limited to a 2, a 3, a 4, or a 6. So halves, thirds, fourths, and sixths. That's what our 3rd graders are working with. So they did limit the denominators. So we're working with halves, of course, the whole. Here's halves, thirds. Let's see. Oh, they're in here. I apologize for the noise. These are a little noisy. But the good thing about these is when you do get back with your kids and they can use these, at least it's something you can sanitize when I know they're noisy, but at least it's something we can make sure it's clean and safe for our kids. And I guess I should mention, thinking about getting our kids back, until you do get your kids back, these tools are available virtually. There's a site I'm going to share with you at the end today that shows you how to all kinds of tools and how to use them virtually. So there's fraction strips actually on there rather. And let's see, we need my 6 pulled out of here. So all righty. So that's for your 3rd grade. That's what they'll be working with. And then, get back. When we get into our 4th grade one, you can see that the limit increases to include 8s and then 10s. So our 4th grade and 5th grade, the limit increases to 8s and 10s. Notice that they're avoiding the 5ths. 5ths are difficult for the kids. It's hard for them to divide things up into that. So those are eliminated for them. And of course, it doesn't go up into 12s for our kiddos. So I'm going to go back and we're going to look at some sample problems. All right, so this one, Shelly is baking and needs 3/4 cup of sugar. And she only has her 1/4 measuring cup. You know, this actually happened to me this past weekend. I was trying to bake and I could not find my measuring cup, the one that had the cup marked off into the 4ths and that type of thing. All I had was my little scoops, and I had that 1/4 scoop. And so it actually did happen that I had to use the 1/4 measuring cup. So how many times will she need to fill her measuring cup to make 3/4? So you can have the kids think about how many, pull out their 4ths. So these can represent the measuring cup. And how many would you need to make 3/4? We got 1, 2, 3, and they can line those up and they can look at it. They can put them together. If they need to, you can put your plus signs in between. 1/4 plus 1/4 plus 1/4 equals 3/4. Okay. So you can actually could show that in the abstract form as well. You can have them draw it if you need to. What 1/4 plus 1/4 plus 1/4 might look like, and label them. And when I say draw, I guess I should show you this right now. I've got some new tools out here. We created one of these work mats for people who attend our trainings because we talk a lot about the CSA model. And the CSA model I've been doing with you all somewhat here today. I've been using the tools, the concrete portion. So for your kids, the ones that have that dexterity, the ones that can write, you can move them into that semi-concrete level to where they at. Let's see, I've got some things in chat. Let me make sure. Oh, great. Yeah, Angie says that she uses the mat a lot. Great, Angie. What's nice about it is it reminds us to have the kids to do it. And if they do it enough, then I'm assuming it becomes automatic for them, that they'll think about, okay, I'm going to model it first, then I'm going to draw it, then I can write it. So let's do that with this one. I won't do it with each of them just for the sake of time, but with this one, I want to do that because we've modeled that this is 1/4. And also the kids need to prove to themselves that it's 4. So you'll need to have them model. And see that each one of those, that it takes 4 of those to equal that one whole, and that these are 4s. And so we're going to use 3 of them. So 1/4 plus 1/4 plus 1/4. So they can actually draw that on a work mat. And I always told my kids, you know, this is not art class. It doesn't have to be perfect. And if they can label them, that's even better. And if not, that's okay. And they can show the 3/4 and they can write it 1/4 plus 1/4 plus 1/4 equals 3/4. And that puts it in that abstract for them. Now I can drop this also. I will move this. Actually, I'm going to make myself a note so I don't forget. But I'm going to move this into, I want to write it so I don't forget, into that Google Classroom. So I will remember to do that. I'll try to do that during lunch. So you guys will have a copy of that. But I do highly recommend that you use this with the kiddos. It really helps to move them out of the concrete into the semi-concrete, and it helps them link it to that abstract. And when we say abstract, it's abstract to our kids. It doesn't make sense. But if we can give them something to look at and move around, and if they can draw it, then they'll have a better understanding of the abstract with those symbols. All righty. So I'm going to take that away. Just keep that in mind whenever we're modeling, that we always want to think about drawing it and then moving into that abstract. All right, the next one I want to share with you. What fraction is equivalent to 1/2, and how could you prove it? So that is a 4th grade standard, and equivalent fractions is what we're working on. So let's think about what we could use for our 1/2. What could we do? What's equivalent to 1/2? Well, think about what you have here. You've got your fraction strips. We can see that this is marked as 1/2. So you could take your other fraction strips. The kiddos could take those. And remember, this is 4th grade. So our limit is within 10. I mean, up to 10ths. So we could think about, okay, what could we use? What else could we use here? All right. So let's think about 4ths. So let's build with 4ths. So how many 4ths does it take to equal 1/2? Well, it takes 2 4ths to equal 1/2. I wonder if we could do 3rds so they can experiment and look and see. It's really important for them to see non-examples as well as examples. Well, that one won't work. And then let's move on to 6. And let's see how many 6 we can build under here to equal 1/2. And then we can move on to our 8s. So it takes 3 6. Looking at our 8s. 4 8s. And then our 10s. All right. And of course, as they build this, they're proving to themselves what equals 1/2. Now, I always like to have mine build them underneath each other. But if they need to just pull them away and do them one at a time, that's okay too. But they're going to need to record what they're seeing here. So, for example, what's equivalent to 1/2? So 1/2 actually equals 2 4ths, which is equal to 3 6, which is equal to 4 8s, which is equal to 5 10s. So that's how we could record that abstractly. If we wanted to do the semi-concrete, we could actually draw these and just draw them into, make our little rectangles and label them. 1/4, the 6th, and the 8ths, and the 10s. Okay, so that's one way. That's one tool that they could use. It's probably the best tool for our kiddos because they're labeled. But if they're ready, and if they can, then they could use this tool. Now this tool is your fraction square. It's the brown one. It's kind of hard to tell the color on here, but it's the brown one. And then you have all your other fraction squares over here. Remember I said that what they did really nice for us is they coordinated our colors. So we know that the yellows are fourths. So I can see how many fourths it would take to equal. And what I like about fraction squares, and something I like to do with them, is I build right on top of them. So it takes 2 fourths to equal 1/2. So they could prove that one. Looking at our 6, we've got our 6, and this is another thing because it has them look at it different ways. You have to build it differently here. So we have the 3/6, which also equals 1/2. Now, if they need to prove to themselves that these are 6, though, you have to let them build on the whole. So they have to build it. Of course, this is something you let them have lots of experience with, building and seeing how many orange ones can we fit on the whole, and they would build them. All this is done prior to ever trying to attempt those equivalent fractions, guys. Put these tools in their hands and let them explore with them. And then you would do the same with the 8s and the 10s to cover that half, what equals 1/2. So that's another way you could do it. One way, trying to find a better sheet of paper because I didn't get out my, here we go. This will work better for us. You take a strip of paper. I'm going to fold this in half. I think I've got 2 here. So I fold it in half. I'm going to draw my line. Okay, and I see that I've got, it's kind of hard to see on that white, I've got 2 parts. Okay, so this is 1/2, this is 1/2. So right on this line, I'm going to label that it's 1/2. Okay, and then I'm going to fold it back up and fold it again. And the kids unfold it, and we see, and they draw on those lines, those creases, the folds they've made. And you see you've got, now it's divided into 4 equal parts. And again, it's important to talk about how fractions are equal parts. So this is 1/4. So this would be 1/4. This would be 2/4. 3/4. 1/4, 2/4, 3/4, and over here would get us to 4/4. If we were looking at this as if it were a number line, that's how you need to think about it. Like this would be 0 over here. Okay. And then you can fold it again. And they can open it up. Drawing those lines again. And we see that now we have 8 equal parts, and they would label the 8s. And what they will discover is that when they're labeling those 8s, they're labeling. So here you can see what's equivalent. What's equivalent, and actually 2 8s. We'll go ahead and label this one so you can see what's equivalent there. The ones that fall on the same line are equivalent. So it's a good way for the kids to discover on their own what equivalent fractions are. Okay, one more with fractions. So let's look at a 5th grade one. Mary ate 1/3 of a pizza. Tommy ate 2/3 of the pizza. How much of the total pizza did they eat together? So we're looking at 1/3 and 2/3. 1/3 and 2/3. So they can actually build 1/3, and that's what Mary ate, and 2/3, and that's what Tommy ate. And we put them together, and that's 3/3. And you can talk about how 3/3 is actually equal to 1/2. So the kids will learn. So it's important to show them that you can write a whole as a fraction as well, equals 1/2. So that's why it's important for them to build those fractions underneath that 1/2. And always refer back to that. The fraction depends on the size of the whole. That we are now talking about multiplication and division. And there are several standards in the elementary, at the elementary level, related to multiplication and division, kind of similar to the fractions, very close number. So that's another huge chunk of our work that we focus on at this at this level. So you can see there's 3 standards in the 3rd grade. That's around multiplication division. There's 2 in the 4th grade, and there's 5 in the 5th grade. And again, we're not going to look at every standard. Time just won't allow, but we're going to look at one from each grade level. And then, of course, you'll have this PowerPoint to look at, and I'll give you several sources in order to get to these standards and look at them the way that I've got them organized for you. So let's first of all talk about some tools that we might use with multiplication division. Obviously, the Unifix cubes is one of my favorite go-tos for this. The bead string, we can use the number line. Of course, we can use our base 10 blocks. We can, of course, the grid paper. It's always good to move them to that grid paper. It's where they can do that semi-concrete representation. Then, of course, we can always, it helps to have a place value chart for them to think about ones and tens and hundreds and even into the thousands, and then, of course, even back to thinking about decimals. Fraction strips can also be used for multiplication and division. Money. We can think about money with our kids. Like I said before, they relate to money, they relate to food. And then also bundles and sticks was another good resource for that. And of course, like I said before, this not an exhaustive list. It's just a suggested list of tools to use for this. So some sample problems. Our first one is the 3rd grade standard. Sam has 5 boxes of crayons with 8 crayons in each box. So how many crayons does he have in all? All right, this is something that the kids can represent fairly easily with tools and manipulatives. My favorite go-to, like I've said before, is my Unifix cubes. And what I would have my kids do when we were working on this, I would have them make their groups, determine what the groups are. First of all, the group size. So we're looking at, he has 5 boxes. That's like 5 groups of. So we would actually make our groups. And I actually used solo cups with my kids, and we would put them into our solo cups. But so you can be able to see a little better here today, I'm going to just put it on the whiteboard for us. So I would make my groups. May not be large enough. And then I would put 8 in each group to represent the boxes. So to represent my 8 in each box. So I've got trains of 10. That's another reason why I put these in trains of 10. And I always had my students, whenever we were finished at the end of a class period, their job was to put my Unifix cubes back together by color in trains of 10. And they were conditioned to do it. That was a requirement for my class, and they were pretty good about doing that for me. So I know I've got 8 and 8 and 8 and 8 and 8. So I can represent it this way. You could break them apart. Actually, you could have them break them apart if you wanted to, and then put them back together in trains of 10 in order to find out how many in all. They could problem solve about how they would want to go about doing that. What would be the easiest way for them to do it? My kids got pretty good about solving problems that way. So if they're looking, they know they've got 8. How many more would I need to get to 10? Then they know that just needs 2 more. Again, another advantage of them making groups of 10. because they get really good at being fluent to 10. So there's one train of 10. Here's another train of 10. I'll take two more, another train of 10, with this one, another train of 10. So I can see very quickly that I have 40 in all. It's one reason why I like these Unifix cubes. I like them way better for this type of work than the rods that come with their base 10. Base 10, like I said, they have a place and a purpose, and they're great for building numbers. But if you're wanting to decompose rather, and compose numbers, then these Unifix cubes are way friendlier for that. Okay, so that's a model of how you can model that one. That's not the only way you could model it. You could use different tools, you could use different resources, and of course you would, once you had done this with your concrete, you could have moved it to the semi-concrete where I would draw, and I would put 8 in each group. And I do that for each group, and I have the kids do that. And then you could move to the semi-concrete where you would actually write the equation, which would be 5 groups of 8 is 40. And I always taught my kids that that's what the multiplication symbol means. It means groups of. And then, of course, the equal sign is. All right. Any questions on that one? Okay. Our next sample problem. Pizza costs $6, and that is 3 times as much as a hot dog. So how much does a pizza cost? Kids have a hard time with these types of problems because we're not asking for the result. We're giving them the result. We're giving them the fact that it costs $6. And we're telling them that it cost 3 times as much. We're looking for this piece, is what we're looking for here. So the kids have to think about 3 times 3 groups of what will equal 6. So they can do that different ways. They can think about the fact family with multiplication and division, and they can think about, okay, 6 divided into groups of 3 would be how many groups, or 6 divided into 3 groups, how many would be in each group. They can just model it and see. They can make 3 groups. And they know they need 6, so they can get out 6 counters, 6 Unifix cubes. And they can do a fair share. 1, 2, 3, 4, 5, 6. So I've got 3 groups, and I have 2 in each group. So those fact families that we talk about in the early primary, they are important for our kids to know. It's important for them to be able to use those with multiplication and division just as well as with addition and subtraction. So that's something that we also have to work with and stress with our kids when they're trying to attack a problem. What do they need to think about? Think about the scenario. 25 times 34. So that's KY 5 point NBT 0.5. So KY 5, it has a limit on it. It's products, but it has a limit on it. It's products within 1,000. So that keeps our numbers, the numbers that we're multiplying, our factors, fairly low. So our kids will be able to work with them and actually build those numbers if they need to. So I want to show how we can do that using the area model. So with an area model, what we do, kids have to know how to expand numbers. First of all, they have to know that 25 is equal to 20 plus 5. So they may have to build that in order to see it. They may have to build 25, 20, and 5. And then they have to be able to understand, of course, that 34 is equal to 30 plus 4. That's something that they would have to have, some background knowledge they would have to have in order to do this. Okay? So once they know that, we know that they know that, then they can multiply 25 times 34 using an area model. What I mean by area model is just a rectangle. And we're going to think about 25 is 20 and 5, and 34 is 30 and 4. And what we're going to do here is we're going to multiply. And we're going to think about 20 times 30, and that would be 600. And then 5 times 30, which is 150. And then 4 times 20, which is 80. And then 5 times 4, which is 20. And once they've got that done, then they know that they can put all that together. So they can add it up, 600, 150, 80, and 20. And they can add that up to get the product, right? So I always like to try to have mine think about place value and think about trying to do these mentally as much as possible. So I would have mine think about 80 and 20. We know that 8 and 10, 8 and 2 is 10. So 80 and 20 is going to be 100. So that's going to give me 100 there. So 600, 700, 850. Okay. So we want our kids thinking about place value, thinking mentally, if they can do that. If they can't, then we can give them tools to work with to model that, to model those groups that we're looking at. Any questions on any of those? Back up and show you how to do this multiplication with this grid board that we gave you, because it is a very nice tool. So if you're wanting to, a way to use this would be if you wanted 5 boxes of 8 or 5 rows of 8, talking about rows and columns. So we can have 5 rows. So I'm going to shade 1, 2, 3, 4, 5, and I'm going to go over 8. 1, 3, 4, 5, 6, 7, 8, and 8 again. Do this quickly so we'll move on. But I wanted to show you how the kids could do this too. This is another way to move that into that semi-concrete. Right? So we've got 5 rows with 8 in each row. So we can count those by 5s if we want to. 5, 10, 15, 20, 25, 30, 35, 40. Right? So that's just one way you could do that. Or you can add them up, or you can think about them as if they were repeated addition. Maybe 8 plus 8 plus 8 plus 8 plus 8, or 8 5s. You could do it, record it that way. Okay, so just another thought I wanted to share with you on that and how to use this grid board for that as well. Okay, let's move on to our next strand, which is geometry. Geometry was one of my favorite subjects, favorite parts of math to teach with my kiddos. I always enjoyed it. Um, so let's move on. Like I was saying, geometry was one of my favorite parts of math to teach. The kiddos really seemed to enjoy it. We got to use lots of tools. We'd pull out our pattern blocks. They love to make those shapes. They love to be creative. So some of our tools here, of course, are the pattern blocks. Any type of shape, a two-dimensional shape that you can find those online. Kids can draw them, make them. We have your Exploragons. You have those in your toolkit as well. You've got geo boards that you can use, and of course, um, your gridded whiteboard to make those squares and rectangles in particular with. Okay, so as you can see, there's only 3 standards in geometry in our elementary. We've got a 3rd grade one, a 4th grade one, and a 5th grade one. So we're going to look at each one of those and just talk a little bit about a sample problem. So one thing we could have with our kids is we can just show them those two-dimensional shapes, those polygons, and ask them to identify them. So before they can identify them, though, we have to teach them to them, okay, right? So, of course, the first one you can see we have an example of a triangle. And the kids, you can talk to the kids about, okay, how do you know that's a triangle? You can't just have them give you a name. They have to be able to explain to you why it's a triangle. And some things they might say would be, of course, that there's 3 sides, there's 3 angles, those types of things. And then the one in the middle here at the bottom, you can see that that one is a square, and talk to them about why, how they know that's a square. Is there another name for a square? Could it belong to another group? Of course, we know that a square is also a quadrilateral. It's part of that quadrilateral family. It's also could be considered a parallelogram because the sides are parallel, opposite sides are parallel. It has 4 sides, therefore quadrilateral. It has 4 angles. You can talk about the types of angles in the square, do all kinds of conversation with these polygons. And of course, we have the trapezoid. And with the trapezoid, you can talk about why it is a trapezoid, what makes it a trapezoid. And you can see that all the sides are not, and only has 1 pair of parallel sides if it's a trapezoid. But it also is a quadrilateral because it has 4 sides. So they love to have lots of conversation and argue back and forth about what they see. Okay, you could, while you're doing that, pull out your geoboard and you can have them make those shapes. We all know if they're using their hands and they're making and using these tools, then they're going to remember it better. It's going to become a nice memory for them. They're going to remember more about it that way. So you see, I've already got my trapezoid built here, but you could have the kids turn that trapezoid into a square. And when they turn it into a square, they're going to have to make sure that all sides are equal. The angles are right angles. You can ask them to turn that into a triangle, a right triangle. They know they're going to have 3 sides, 3 angles. You can have them point to the sides, point to the angles, all kinds of good stuff with this geoboard and with these tools, right? And then, of course, you actually can have the shapes. If you want to, you can pull out your pattern blocks. And these pattern blocks can be nice for that. So we have the trapezoid that you could have out there for them. We have the square. You can move in. Of course, we have a triangle. We don't have a right triangle. We have equilateral, but we have a triangle. You can even get into the rhombus. But that's a quadrilateral. Just all kinds of good stuff. The hexagon. You can get into all those different types of polygons. And of course, we do have limits with that 3rd grade standard. It limits the classification of quadrilaterals to rectangles, squares, and rhombuses. So it leaves out the trapezoid, not necessarily for classification, but for identification, but for classifying it as a quadrilateral. So that is one limitation that's been placed on that one. All right. Now, our next one is the 4th grade standard. And it says how many acute, obtuse, and right angles are in this shape. Of course, I've given you the trapezoid. Let's go back to the trapezoid. Again, they can build it. You can show it to them, model it, and let them make it. Then you can talk to them about those angles. So before they can tell you how many acute, how many obtuse, and how many right angles are in this shape, then they're going to have to know what those are, what that means. So again, an anchor chart would be nice with that on there, just to trigger their memory, to cue their memory. I did notice you have nice little cue cards. I guess this would be a good time to point that out with you all. Let me find those. The document that Cheryl shared with you all this morning, I think she was going to try to get into that. And I know you all had a rough start with the getting kicked out of the meeting. But inside of this document, let me find the page. I should have marked it, but I just had a chance to look at it. This was brand new, hot off the press. But if you look, if you have your document, if not, when you do get your document, it has little cue cards that you're going to be able to use with the kiddos. So it has, and they're in alphabetical order, and they're set up by subject areas. But this one is a cue card for an acute angle. These are really nice. You have a cue card for there's all kinds in here, but the obtuse angle, looking just for the angles here. And of course you have the right angle. So nice little cue cards to give for the kids. So I would put those on my anchor chart. I'd show those because that's ones that you've been given liberty to use with the kids during that assessment, was my understanding of it. Now I always taught my kids, I had little tricks and little sayings to teach them how to do little things. So the acute angle, we talk about how that acute angle, the space in between the angle is small. And so when we see a little puppy, we say, oh, it's so cute. So it's got a little tiny space, like a little tiny puppy. And then we talk about when you go to the doctor and the doctor asks you to say, ah, you have to open your mouth really wide, like a wide angle, obtuse. And then, of course, the right angle, we talk about how that's perfectly straight up, stand up right, stand up straight. So that's just some little tricks that I would use with my kids, and you'd see them doing it. They'd open their mouth really wide for the obtuse, and they'd think about the little bitty acute puppy. So just some little tricks of the trade there. So in this one, then you would, after once, of course, you make sure they know what we're talking about, acute, obtuse, and right angles. And of course, they would be able to answer, and they'd be able to look and see that there are 2 acute angles and 2 obtuse angles. And you have to talk about the space that's inside of the angle. That's also important for our kids too. And you may need to take a little Sharpie and a little dry erase and write on that, because it will come right off. That's what's nice about these when you're looking at the space that's in between them. And you could do that the same way to show. Oh, that doesn't show well for you all though, but you can see. And then it will erase right off. No big deal. Okay. All right. So now let's move on to the 5th grade one. And it says, what are the coordinates of the point on the grid? Now, there are some limitations with this one as well. It all stays within the first quadrant, that positive and positive. The first quadrant up there on the top right is where our kiddos will live. They're still going to need to understand points and coordinates and how to plot those and how to find those, but they're keeping us with positive numbers, and they're keeping us in that top right coordinate up there. They're going to need to know the y-axis and the x-axis. Those types of things are still going to be required to know. But what I was thinking is this geo board, and of course I would keep my numbers really small like I did for us up here, is perfect for that. So what I did during lunch, I thought, hey, this will work. So I took my little geo board I took my dry erase and I plotted my y-axis and I showed my x-axis. This is 0, 0. Now I could have my kids uh, take a tool, sometimes whatever. I'm going to use this Unifix cube and I'm going to plot a point. Let's say I want to plot 2, 3. And we need to talk about what that would look like, of course. I'm just going to write it right on here so you can see. 2, 3. And we've talked to our kids about how X is first, then Y. Just like when we say our ABCs, X, Y, Z. X will come first. So we're going to go over 2, take care of the X first, get on this X axis, and we're going to take 2 hops over. We're going to start here, always start at 0, 1, 2, and I'm going to take 3 hops up because my Y says 3. 1, 2, 3. Right? And you could actually have these numbers if you needed to. You could do 1, 2, 3. We'll go ahead and do that. 1, 2, 3. 1, 2, 3, 4. Right? So I think that's a pretty cool tool. The kids would love to do that. You just give them a coordinate and they find it. Or you can do the opposite. You can lay one down, like in this example. Let's see. It's kind of hard for me to make out what I've got there. I've got it here. And you could ask them to tell you what the coordinate would be. What would it be? Well, where do we have to start? Start at the starting point, and we have to go X first. So we're going to go over. We're going to make 1, 2, 3, 4 hops, and then 2. So it would be 4 and then 2. Okay, I'm going to share with you a couple more that I had. If you think of something, please by all means just jump in there. Let's look at your bead string. The bead string is an awesome tool to show groups of. For example, you can do, let's say we're going to do 3 groups of 5. If we want to model that, then we can pull them over to 5, and then 5 more, and then 5 more. And we can see that 3 groups of 5, and you can take little clips to put on these and model the groups. So there's 3 groups, there's 5 in each group. You can push them together and they can see real quickly that that would be 15. Okay, so that's another tool you can use for your multiplication. The kids will be familiar with the bead string because you've already used the bead string for addition and subtraction. You've used it for identifying numbers. For example, here, like you can show, like you've done things like this. We didn't do this earlier, but like you've just pulled them over and shown this would be 2 groups of 10 and 2 ones, 22. So it's really good for identifying and building numbers. It's an awesome resource to use. Okay. And then another tool that I didn't share with you at first was these nice, cool little exploragons. And these exploragons, of course, could be used for our geometry. We can use them to do what? You guys tell me. Come on, share with me. What could we use these for? Looks like Christmas here, red and green I pulled out. What could we build with them? What could we do? Okay, it's after lunch. Everyone goes to sleep on me. All right. So obviously you can see what I've done here is I've just built these. I've built the square. And what I love about these is you can change the angles. So this square can become the rhombus. We can show this rectangle and compare it to a square and look how it really emphasizes the difference in the two. The difference between a square and a rectangle, but yet they're both quadrilaterals, and yet they both have 4 right angles and 4 sides. So I just love how you can do this. Of course, you can build the triangle. You can also build a triangle. You can build the tops of triangles. You can build an acute triangle. So, and like I said, it's really cool how you can just change those angles and show that I was changing acute to an obtuse and back to a right angle. So if nothing else, you can just have them put 2 together and just show the angles. If you don't want to do the polygon, you can just show the angles. And you can show a right angle, and you can have them change it to an acute angle, and then you can have them change it to an obtuse angle. So all kinds of cool things you can do with this. Those actually would make nice hands on a clock as well. You could do the minute hand, hour hand if you needed to makeshift clock. You needed to use just a paper plate to mark them off. Okay, so just a few more ideas, ways to use your tools. All right, let's move on. And let's talk about patterns now. You can see that patterns and functions, even though we do a lot with patterns and functions, there's not a lot of standards that address it in the elementary, and there's not really a lot of standards, and I definitely didn't choose a lot of standards for us to be assessed on with this. So the only 2 they chose here was one in the 4th grade and one in the 5th grade. So obviously we'll look at both of those. So I want to open these up and look at them so you can see what it actually looks like here. With this one, we're going to generate a number or shape pattern that follows a given rule and identify apparent features of the pattern not explicit in the rule itself. And of course, your ultimate target, your limit, is to identify and extending a rule of or pattern. Okay, so we're just extending it. They're giving it to you, you're just extending it. Okay. So let's go back and look at the next one. Is a 5th grade one. And with this 5th grade one, we're going to generate numerical patterns for situations, generate a rule for growing patterns, identifying the relationship between corresponding terms, X and Y. We're working again in that first coordinate plane. That's where we're living at. And we do have a limit, full standard to 1 rule. We're only doing 1 rule versus the standard, well, we're only going to be assessed on 1 rule. The full standard one, you would have to do 2 rules and all. They would have 2 rules, add 3 to 0, add 6 to 0. So you would work with the 2 to come up with your coordinates. Here, we're only working with the 1 rule for that's our limit. Okay. Now let's look at some situations. Oh, tools first. You can use Unifix cubes to show patterns. You can use number lines to show patterns on the number line. You can use pattern blocks to build with. Obviously, we could use the grid. We could use our, let's look at our sample problems. So if we're going to generate the next step in the pattern, okay, so this one, we can have the kiddos actually build each step. So what I would use my Unifix cubes. You know, I told you I love them. So this would be step 1. There's just 1 cube. Well, step 2, we know that we have to start with that 1 cube, and we look and see what did they do to that 1 cube. Well, they added 1 here and 1 here. I'll need to turn it. Here and here is what they've done. Sorry, I was having a little spatial issues there myself. And then in order to build the next step, we have to create what we'd already created once before. Let's see if I can scoot these over and not have them out of your view. So there's one, there's two. Then we have to recreate two. Recreate two. And you can see that they've just tagged on two more this way. Just my OCD kicks in. All right. So if we wanted to build the next one, we have to create this. And we know we need two more because each time we're putting on two more. So in order to create that next one, okay? So we can have the kids do the building of it. And after they've done the building of it, they can actually use their grid board, and they actually could represent it this way, or they could draw it freehand to represent it that way. But again, it's important to give them those tools and let them recognize and see what's going on. Just see if they can, first of all, fix it, see what's going on, identify what's going on, and then try to recreate it. Okay? So working with patterns, it's important for our kids to have those tools in their hands. Okay. So let's move on to the next one. This next one is a 5th grade standard. Jim knows how to turn 1 cup of flour into 2 cupcakes. So how many cupcakes can he make with 5 cups of flour? So let's and this, of course, this, like I said earlier, this is just the one rule, and that's what we're limited to, is just the one rule. So if we have a table, we have X and we have Y. And we know for 1, it was 2. And for 2, it was 4. And for 3, it was 6. For 4, it was 8. And for 5, it was 10. So after you've done that, you got to talk about, okay, what was the rule here though? What is the rule? What are we doing each time?
Multiples of 2.
Multiples of 2. True. We're doing multiples of 2. What are we doing every time to X? Are we adding 2 every time to X? How do we get from 3 to 6, from 4 to 8, from 5 to 10? What do we have to do? It's like that missing factor. 5, 10. What are we doing to get there? What's going on here?
You're adding the number. You're adding the same number, or you
We're doubling it, right? We're doubling that number. Is that what you're saying?
Yes.
Okay. What would be another way of saying we're doubling the number?
Repeated addition type.
Yes, it is repeated addition. What do we
multiply? You can say it's multiplication.
There you go.
Multiplied by 2.
Yes, we're multiplying by 2. So the rule is to multiply by 2. So every cup of flour you have, you multiply that by 2. Okay, so if you have 5.
But if your children didn't understand to multiply, you can do the double repeated addition. Or
absolutely, yes, absolutely. Most definitely, you could do that. Yes, you could do that. Then that would be the rule, to double the number, which would be like repeated addition, right? 5 and 5, 4 and 4. Absolutely, yes. That is exactly how you could explain it, and you can model that for them, couldn't you? You could actually model. You could actually put out 5 cups. You could put out something to represent 5 cups, and you could put 2 into each cup and to model that. Yes, you could. Okay, good. And then, of course, to take that a step further, you could plot these points. You could go back to your grid and you could plot your X and your Y, because we've been working on that already with our kiddos, how to do that. That's something they got previously. But this is something that's really hard for kids. It's hard for kids, period. But it is difficult for our kiddos. And so it's something that we use those tools and actually model for them and put out cups and then put Unifix in the cubes in the cups, then they should be able to see that pattern. Okay. So let's look at the statistics and probability. As you can see, there's only one standard in statistics and probability. And we're going to look at that one. Actually, look at the target. And it says to identify and gather data for statistical questions focused on both categorical and numerical data. Select an appropriate data display, a bar graph, a pictograph, a dot plot, and make observations from the graph about the questions posed. But we're on our assessment is limited to the bar graph and the pictograph. Okay. Now, the thing here I think the kiddos will probably have the most difficulty with is understanding what's the difference between a categorical data and numerical data. So it's just something we have to teach our kids. Categorical data is something you can answer with a word, a choice of something other than a number, a count of something. So examples of categorical would be like surveying favorite fruits, or surveying a favorite color, or surveying, getting data and surveying a favorite type of car. Numerical data would be to get a count of how many, like surveying people and seeing how many pets do you have in your home, surveying to see how many cars does your family own, or vehicles do they own, surveying how many brothers and sisters do you have. This is where you would get a number for it. So that's the difference between a categorical and a numerical. And you can see over here, hopefully you can see an example of it that's actually on here using categorical is favorite graphs, types of graphs, and they've just done a survey. And over here, this is an example of numerical, some numbers. It's not labeled, which is a no-no, because graphs are supposed to be labeled. They're supposed to have a title, and they're supposed to have each side labeled if you're doing a bar graph. Okay, so that's something we need to address when we put this together that's been left out. Okay, so let's go back to our problem type, or sample rather. So here's something maybe you could ask the kids to do. Survey everyone's favorite school lunch. So after they survey that, then how would you display your data? Would it be categorical or numerical? And explain your choice. So you would have to ask, first of all, when we're in that face-to-face setting, it's way easier to do that than what it is to survey at this point. But maybe they could survey the people in their household a favorite lunch or a favorite type of food. Wouldn't get a lot of data, but it would be a start. But still, the point is, would it be categorical data or would it be numerical data? What do you think?
It really depends on what you're asking of them.
Right. But if we're asking this question right here, everyone's favorite school lunch, what would it be? Would it be categorical or would it be numerical?
For my kids, I would just have a few choices. I already have the words down there, whether it's pizza or, I would just give them like a few choices.
Right, exactly.
Maybe 3 choices. But if you was going to go around, if you stood there and say how many, like how many kids like pizza, then they would raise their hands, you could count and then go up and, and color those blocks in or whatever.
Right, exactly. Yes.
So I guess it really depends on how they phrase that. If you just
right, it's when you set your graph up, when you set up your graph, like if we were to do favorite lunches and we were going to offer pizza, like you said, as choices, and I did the same thing too, because it would get and say,
if not, you'll have 100 choices.
You're right. Pizza, nuggets, hot dogs. And once you got that this is lunches, and this is votes. And I'm going to give it a title. And I apologize for scribbling. Favorite lunches for as a title. Of course, this is starting at 0. And then let's see, let's do mark it off into groups of 5. Let's say this is 5, 10, 15. And they go around and they get their data. As they're getting their data, though, the data they're getting is about the answer that people are going to give them is going to be either pizza, nuggets, or hot dogs, right?
Right.
As you go to each person. So if they give you pizza,
Yes.
nuggets, hot dogs, then that makes it categorical.
Right.
Because it's a category. They're choosing a category. If
Right.
we were surveying how many pets they have in their home,
It would be
be
numbers.
numerical, right? It would be in numbers. To me, that's how I think about it. If the answer is going to
That's
be
me too.
something other than a number, then it's going to be categorical. That's how I've got it in my brain. That's how I understand it.
I guess, yeah, I guess it just really depends on, I mean, it really depends on the type of question that you're going to
It
ask,
really,
which way you're going to do it. I
yes.
mean, you're going to take your numbers and make it into a graph, but because I'm sure they'll have to do the tally marks and stuff first, to know.
Yes, you're still working with numbers. Absolutely.
Yeah.
You're still getting a number. You're getting a count of pizza. You're getting a count of nuggets. You're getting a count of hot dogs.
Mhm.
But the question you're asking is a categorical question.
Right.
So to me, that's it. If you're asking for them to give you a number, it makes it numerical data. If you're asking for them to give you a category, a choice of something other than a number, then it becomes categorical. So you're right. It all depends on the question.
If your question asks, and how many siblings do you have? 1, 2, or 3?
Right. That would be.
How would that be?
Oh my goodness.
Because you're dealing with numbers, but
You're dealing with numbers, but you're giving them a choice. So that does make it categorical. Yeah.
Yeah.
Yeah, it does. Yeah. Yeah, that would there. Good point. Good question. Which is a tough concept for our kids to understand. If we're having to have this kind of conversation about it, think about our kiddos. But you hit it dead on. It definitely depends on the type of question you're asking, what kind of data you're getting. Yeah, we've got one last one here with expressions and equations. Of course, your tools here could be an order of operations anchor chart. You could use some wiki sticks or macaroni or a red marker pen, and you'll see what I'm talking about, why those are some suggested tools here in just a minute. But let's look at what it's actually expecting the kids to do. It says use parentheses, brackets, or braces in numerical expressions and evaluate expressions that include symbols. Okay, so with our kiddos, though, our limit is to just use parentheses, okay, within problems. So they're going to need to understand order of operation, the PEMDAS, those things. That's what I was talking about with the anchor chart. So let's go back to, let's look at our situations. I've got a few of them on here for you. Okay, so let's look at that very first one. And what I suggested, the reason I was saying to use a color, and I forgot to get out a color. My bad. But you could use, let me just write it on here with this, because I do want you to see what I'm talking about. I'll just write it on my paper. All right, so let's look, and hopefully you'll be able to see this. This is all I have is these little pens that are in color. So we're doing 2 times. What I was saying about using a color is make those parentheses in a different color. I always like to use red because it catches my eye. I have been known to take macaroni and dye it red, and the kids would use it in my case, I used it for apostrophes and commas back in the day when I was teaching language arts as well. But because I never taught at this level where I would have to teach the kids about parentheses at that time, but I could see where we could use it for parentheses as well. So you could do that. You can use the little wiki sticks, which will stick to the paper, and you can curve them. But anyway, you talk to the kids about whatever's in red. That's what you do first. That's the thing about this. It's just getting them to take care to think about it that way. So obviously, 3 and 7 is 10, and then they think about 2 times 10, which equals 20. Okay. Not talking, you talk to them about how you don't always start at the left and work your way to the right like they're used to doing. You look and see, are there parentheses? If there's parentheses, you take care of that first. All right. Okay. So let's get into uh, these resources. So, first of all, I want to show you this resource, and this is showing the progressions. This is something else that we put together as we have 8 co-ops in the state of Kentucky, and each co-op has math consultants, and those math consultants got together and we put together these videos for you. So if you want to, and they're put in what they're progressions of how things progress, each topic here. So there's an overview that you could look at and kind of gives you an idea of what it looks like. And then we've done each one of these. There's one on expressions and equations. You can click on that if you want to see how expressions and equations begin in the early elementary all the way up through high school. Same thing with fractions. There's one with geometry, and it's at your own pace. So you can just you have to click to progress to make the slide go move on. It's not a video that you sit and watch per se. You have to advance each slide, so you get to do it at your own pace and your own time. And you can see there's one for geometry, measurement, multiplication, division, number sense, patterns and functions, um, ratio and proportions, and then there's statistics and probability. Okay, so that's a nice resource. If you get into your alternate targets, if you get into them and you're just not quite sure where this is going, where it came from, why am I starting here? This would be a good place to go to watch the little videos and get some knowledge about it and get some training on it. Then, of course, this is a complete set of the academic standards for mathematics. And this is on KDE's website. It's kystandards.org. But like I said, you will have all these links. And this is this is a math. This is all of them. This is language. This is your math. So if you click in your math, it takes you to a PDF. But what's nice about this PDF is that it is interactive. And I don't want to make you sick scrolling, so I'm going to see if it'll advance me to, let's go to the 4th grade. Yeah. So it advances. What's nice about it is that the table of contents is interactive, showing these 3rd grade standards. And you can see it looks a lot like your targets do. And it also has this coherence piece in it, which I forgot to mention earlier, so I'll mention it now. This coherence piece which shows you where it's going. And in some cases, when you get on later on, it's where, what was taught prior to it in that progression. So it shows the progression also. So this is a nice way to see where this standard is going. I mean, this standard will go into also be seen in 4th grade and also seen in the 5th grade. So it's building for them. So that is kystandards.org. Don't want that. All right, here we are. This is the site that takes you to all types of resources for that's also on KDE's website. You can see it's all about your alternate your K-Prep trainings, resources, all types of things like that that you can go and look at this later. So this is something else, a link that you might want to check out. Now here's our manipulatives. I wanted to share these with you because they're awesome, especially for the time that we're in right now. So this is Toy Theater, and some of you are familiar with Toy Theater. Some of you have been using it. I haven't used it obviously with students, but I have been in there playing around with it, and it is pretty awesome, the things that you can do with it. Remember we were talking about the clocks. It's hard to get the kids' hands on those clocks, especially now. Um, all types of stuff with fractions, the fraction bars. I know we may not be able to get them in the kids' hands, but we can at least give them a tool that they have to move around and manipulate, like these fraction strips. Click on that one real quick. And I'm going to pull this over so you can see a little better. But you know, I love how that we can pull up that one hole, and then we can pull over our halves and see how many halves, 1/2 it takes to make a whole, how many thirds it would take to make one whole. I really was very impressed with this site, and all the things that you could do with it. But you can see there's just tons of stuff on here that we can do with the kids. Here's the geo boards. I know we can't put them in their hands right now maybe, but we got them here. Place value charts. There's number lines. Like I said, I've not even scratched the surface of it, of looking at it, because you can see it seems endless what's on here. Here's money, thermometers for measuring temperature, coins for counting, the reckon racks. Those are a nice tool as well. You have your frames, 5 frames, there's 10 frames, there's part holes on here. It's just awesome. It really is. It's a great site. Have any of you used this one? I know some of you have because I've talked to you about it. Can anyone add something to that? What I've said about it? Angie, I know you have. Okay, here's somebody in chat. Let's see what we got. Okay, sorry, I didn't see your chat earlier, Sharon. I can't see the chat when I'm sharing my screen. It doesn't pop up. I have to purposely go and look. All right, so let's look at one last one. And I discovered this one last night. See if I can get it to where I can click on it. Well, here we go. So this is virtualnerd.com. And what I liked about it is that it has, so you could go to your grade level, and it has it by your groupings here. You have your operations and algebraic thinking, your MBTs, your MDs, and your geometry. So I like the way that you could click on one of these. Let's look at numbers and operations, and use place value, understanding properties. It breaks it on down for us. And then some little videos to explain it a little bit for us. So this is the one with the associative property. So I thought this was a really nice site for us. I really like the way that it was by grade level. So it makes it easy to search for those standards, in my opinion. Okay. Again, if you have any questions, or if I can help in any way, if you want to just do a Zoom call and I can help in any way, talk you through something, go over something. If I went too fast, I will get this recorded, and I mean, it is recorded, but I will get it edited and posted in that classroom for you, so you can watch that back if you'd like. But if you'd just like to talk to me, or just do a little Zoom session or email back and forth, You can get me at Vonda.Adams at theholler.org is my email address. And I'll be more than happy to help out the best that I can.